Assalamu alaikum. Welcome to Let's Explore Mathematics. Our today's video is about real life applications and problems of proportions. Our first problem is the surface area A of a cube varies directly as the square of length L of an edge, and A is equal to 27 square units when length is equal to 3 units. As we know that a cube is a three-dimensional figure, we have a cube here. We can see that it is a three-dimensional figure having height, length and width. So the three quantities make it a cube. A cube has 6 faces and all these faces are in square shape, like the one here in blue, the one in pastel green, the one in pink. The 3 faces are behind this. It has 8 vertices and 12 edges. Our statement says the surface area of a cube varies directly as the square of length. So writing it in the mathematical form, we have area is directly proportional to length square. Replacing the sign of proportionality, we get K. So area is equal to KL square. We call this equation 1. Putting area equal to 27 square units and length equal to 3 units in equation 1, to find the value of K, we get 27 is equal to K times 3 square. On solving, we get in equation 27 is equal to K times 9. Solving it for the value of K, we get K equal to 3. Now we can write equation 1 as the surface area of the cube varies directly with 3 times L square. The surface area S of a sphere varies directly as the square of the radius R, and the surface area is equal to 16 pi when radius is equal to 2. We have to find the radius when surface area is equal to 36 pi. So what is a sphere? The common balls we hold in our hand, the golf ball, the tennis ball, the volleyball, etc. and all such objects are spheres. Here I have a golf ball. You can see that it is a sphere. This pink region of the sphere shows the central part of the sphere. At this point, we can divide the sphere into 2 equal halves. Each half is called hemisphere. The radius of the sphere is the distance from the center of the sphere to the boundary. Now the statement says the surface area S of the sphere varies directly as the square of radius. So if we write it in mathematical form, we get surface area S is directly proportional to R square. Removing the sign of proportionality and replacing it by equality and K, we get S is equal to KR square. Let's call this equation 1. Now we put the value of S equal to 16 pi and the radius equal to 2 in equation 1 to find the value of K. We get 16 pi is equal to K times 2 square. Solving it, we get 16 pi is equal to K times 4. Solving it for the value of K, we get K equal to 4 pi. Now we put this value of K in equation 1 and get a relation surface area is equal to 4 pi R square. Now we have to find the value of R when surface area is equal to 36 pi. So putting this value in equation 2, we get 36 pi is equal to 4 pi r square Solving it for the value of r square, we get r square is equal to 9. Taking square root on both sides, we get r is equal to 3. We are ignoring the negative value of r because we know that a radius is a distance and distance has only magnitude without any direction. So the radius is 3. The statement says, in Hooke's law, the force F applied to stretch a spring varies directly as the amount of elongation S and force, which is equal to 32 pounds, when the elongation S is equal to 1.6 inches. Before starting the question, we should understand what is Hooke's law. To understand the Hooke's law, we are considering two springs. Let this be spring 1 and this one be 2. We add some weight to spring 1, we add a smaller weight to spring 1 and a greater weight to spring 2. As we know that weight is equal to force, so we are calling force here. The stretchness in the spring 1 due to smaller force is less as compared to the spring 2, which has greater weight. So, smaller the force, smaller the elongation. Greater the force, greater the elongation. So, we can write the Hooke's law in mathematical form as force is directly proportional to elongation, extension, or we can say that the stretchness. So force is directly proportional to S. We replace the sign of proportionality by equality and K. We get F is equal to Kx. Putting the value of F equal to 32 and S equal to 1.6 in equation 1, to find the value of K, we get 32 is equal to K times 1.6. On solving, we get the value of K, that is 20. Putting this value of K in equation 1, we get a relation F is equal to 20 times S. The intensity I of the light from a given source varies inversely as the square of the distance from it. If the intensity is 20 cp, the cp stands for candle power. So, if the intensity is 20 candle power at a distance of 12 feet from the source, find the intensity at a point 8 feet from the source. Before starting this question, we have to understand the statement. For this, consider this diagram. This is a light bulb and this is 3 screens. The intensity of light to the first screen is greater, but the intensity of light for the second screen is a bit less, and for the third screen it is reduced. So, farther the objects from the source of the light, smaller the light intensity they will have. Or we can say that the intensity of light from a given source varies inversely as the square of the distance from it. We can write this statement in mathematical form as intensity is inversely proportional to the square of the distance from the source. We can replace the sign of proportionality by K and get a new equation. Intensity of light is equal to K over distance square. We call this equation 1. Putting intensity of light is equal to 20 and the distance equal to 12 in equation 1, to find the value of K, we get 20 is equal to K over 12 square. On solving, we get 20 is equal to K over 144. Solving it for the value of k, we get k is equal to 2880. Putting this value of k in equation 1, we get a new relation. Intensity of light is equal to 2880 over distance square. We call this equation 2. Now we have to find the intensity at a point 8 feet from the source. So putting distance is equal to 8 in equation 2, we get intensity is equal to 2880 over 8 square. Solving it for the value of I, we get 45. So the intensity of light is 45 candle power. The pressure P in a body of fluid varies directly as the depth. If the pressure exerted on the bottom of a tank by a column of fluid 5 feet high is 2.25 pound per square inch, how deep must the fluid be to exert a pressure of 9 pound per square inch? To understand the statement, let's have a look on this diagram. This is a water tank. It has 3 nozzles. When we put on the first nozzle, the pressure is less. When we put on the second nozzle, the pressure increases. So, with the increase in depth, the pressure increases. And for the third nozzle, the pressure is maximum. So, increase in depth increases the pressure and decrease in depth decreases the pressure. I hope you like our today's video. Please give your feedback. And also like, subscribe and share our channel. Allah Hafiz.